Let us do a problem on Liebnitz theorem, or rather a problem based on Liebnitz theorem. If y equal to a cos log x plus b sine log x, prove that x square yn plus 2 plus 2n plus 1 x into yn plus 1 plus n square plus 1 yn equal to 0. So we have the question: if y equal to a cos log x plus b sine log x, then prove that x square into yn plus 2 plus twice n x yn plus 1 plus n square plus 1 yn equal to 0. Proof. Given we are given y equal to a cos log x plus b sine log x. Then what can you say about dy by dx? Then differentiating both sides with respect to x, we have dy by dx equal to derivative of cos is minus sine and then ddx of log x is 1 by x. Derivative of sine is cos and ddx of log x is 1 by x. Let's take x to the left hand side, so we cross multiply or multiply by x throughout to have x into y1. y1 is nothing but first derivative y, dy by dx. I can write it as y1 a sine log x plus b cos log x. Well, what to do with this a sine log x and b cos log x? We can't completely eliminate it out, so let's differentiate it once again. So here I should write differentiating with respect to x. So you are given y equal to a cos log x plus b sine log x. What we did, we differentiated with respect to x, and dy by dx equal to minus a sine log x, ddx of log x is 1 by x. ddx of sine is cos, derivative of sine is cos, and derivative of log is 1 by x, and we have multiplied by x throughout to get x into dy by dx equal to minus a sine log x plus b cos log x. But that's not enough for us. We want a simple expression. If you look at what we need to prove, there is no way anything like log there. So what do we do then? We differentiate it again, differentiating again. Above expression. Second time with respect to x. So you have x into y1. Let's apply product rule. First function into derivative of y1, that is y2, plus derivative of x, that is 1, into y1. What about right hand side? Derivative of sine is cos, and after that derivative of log is 1 by x. Derivative of cos is minus sine, and derivative of log x is 1 by x. Again we multiply by x throughout to have x square y2 plus x y1 equal to minus a cos log x minus b sine log x. What is that? Well, that is just y. Oh, that is just y, but minus sign is also there, so that is minus y. Now we have got a quite simple expression. You might also be tempted that, okay, I'll solve for a and b from y equal to a cos log x, this equation and this equation, and at last differentiate again and put a and b there. That will make it complicated. Better just differentiate it again, and derivative of cos is minus sine here, derivative of sine is cos here, and you have got a simple expression here. Let's take y to the left hand side. We can do it later on also, but let's do it here itself. And we have x square double derivative of y x single derivative of y plus y equal to 0. And we apply Liebnitz rule or Liebnitz theorem. Applying Liebnitz rule, comma, what is Liebnitz rule? Let's write it here itself. U into u into v, nth derivative of that is u into nth derivative of v plus nc1 first derivative of u n minus 1th derivative of v plus nc2 second derivative of u into n minus 2 derivative of v, and so on. Okay, let's we will apply Liebnitz rule for product of function, and we have how many product of function here? 2 of them. Oh, we differentiated n times and apply Liebnitz rule, so your u is x square. To get, applying Liebnitz rule, comma this, to get x square into nth derivative of y2 nc1 first derivative of x square into n minus 1th derivative of second v is y2 and you have n minus 1th derivative plus nc2 0th derivative, first derivative, so second derivative now, x square second derivative, and your y2 n minus 2 number of derivative plus x square third derivative, nc3 third derivative x square is 0 into whatever be it, 0 into anything is 0, rest of the term will all be 0. Same thing, we'll apply Leibniz rule on the product x into y1. So x into nth derivative of y1 plus n choose 1 first derivative of x into n minus 1th derivative of y1 n choose 2 second derivative, but second derivative are all 0, second derivative of x is 0, that goes 0. So we have applied Leibniz rule to this product, whatever y, only one, so if you are taking nth derivative, you have just y nth, and nth derivative of 0 is 0. Let's simplify this expression. X square as it is, second derivative of y and nth derivative of y. In total we have n plus 2 derivative of y plus n first derivative of x square is 2x. Second derivative of y and n minus 1 derivative of y. So you have 2 plus n minus 1 is n plus 1th derivative of y. n choose 2 or nc2 is n into n minus 1 by 2. Double derivative of x square or second derivative of x square is 2x. and your second derivative and n minus 2 derivative. In total you have nth derivative. That's all. We have got this expression: x square yn plus 2, n to n is n, x square first derivative 2x, second derivative and n minus 2 derivative, total n plus 1 derivative, nc2 n into n minus 1 by 2, x square. If you differentiate it twice you get, if you differentiate it once you get 2x, but you are doing it twice, so you just get 2 yn as it is, n minus 2 and second derivative, plus what about this expression, x into yn plus 1 plus derivative of x is 1, n into 1 into yn plus yn equal to 0. Can we simplify further? Yes. 2 we can cancel, and ultimately we can write, what can we write? This implies x square yn plus 2, yes, yn plus 1, take common, 2n plus 1 x into yn plus 1 plus yn. Oh yeah, we can cancel something here. N square minus n plus 1 yn equal to 0. n I can cancel, and we can write it as x square yn plus 2 plus 2n plus 1 x into yn plus 1 plus n square plus 1 yn equal to 0, the end. Thank you.